Hey everybody. So this video is going to be a brief one. It's going to be about redox reactions. I'm just going to do a real quick overview of it. And redox reactions are those in which we're going to see oxidation and reduction of electrons in molecules. So with that said, just a real quick intro. Oxidation and reduction are opposites. So oxidation is the partial or complete loss of electrons. Whereas reduction is the opposite. It is the partial or complete gain of electrons. So a redox reaction, whenever something is being oxidized, something else is being reduced. In order to remember oxidation versus reduction, which one's gaining and which one's losing electrons, there's a couple of ways to remember it. The first is Leo the Lion says grr. It helps people remember that loss of electrons is oxidation. So Leo, loss of electrons is oxidation. Grr, gain of electrons is reduction. The way I like it is oil rig. So oil rig is oil, oxidation is loss, rig, reduction is gain. So if we look at the next slide, this is just a general redox formula just to show you what the heck's going on. You can see here with Xe, it's just showing that molecule X has electrons, and when it's oxidized, those electrons are going to move to Y. Y does not have the electrons, but in this reaction, it's going to gain electrons, which makes it reduced. So as you can see, Xe having electrons, at the end of the reaction, it'll just be X by itself, electrons moved. Y begins alone, at the end, Y has the electrons, so it's being reduced. All right. This is stuff that makes sense. Don't let the words, confuse you or overstimulate you. Just think about it. Electrons are going to lose their potential energy as they move towards a more electronegative atom. Meaning, beforehand, they have energy. It's stored. It's ready to go. But throughout the reaction, as those electrons move towards a different atom, they're going to lose that energy, right? They're going to lose that potential energy. They're going to convert it into kinetic energy. Oxygen is very electronegative, meaning that it likes to suck electrons towards it, all right? It's going to pull them close, kind of like a magnet. Therefore, in redox reactions, we're going to see electrons move closer to oxygen, release energy. So in this example here, glucose is going to be oxidized, and then oxygen is going to be reduced. So as you can see, the hydrogens from oxidation are going to go from C6H12O6, and you're going to see that H leave the CO, and it's going to want to bind with the oxygens here. Hence, it's going to be reduced. All right. Then the opposite happens with the carbon dioxide. It started off as C6H12O6. Those hydrogens left, and now it's oxidized. So that's just a general redox reaction, but what you can see here is how the electrons are moving throughout this process of cellular respiration and the movement of energy from high to low states based on the redox reaction. So if you have any specific questions on redox reactions, please let me know, or you can look into it a little more detail in your book.